So in this video, I'm going to cover something called the unit circle, which is a tremendously useful tool for remembering all sorts of trigonometric properties. We'll get to that in a second. What I want to do first is just review some of the very basics that I'm going to use as I scroll down the page, and I'll show you where this goes. So if you remember, sine of theta, what is that? That's opposite over hypotenuse. And for this triangle that I drew right here, if you think about what sine of theta is, that is opposite is y, hypotenuse is, oh, I didn't say that. That's important. Let's call the hypotenuse 1, okay? It's just a length of 1. So that would be y over 1, which is y. And cosine is going to be adjacent over hypotenuse, which is x over 1, which is x. Now this assumes that the hypotenuse is a length of 1. And if that's true, we're going to get into some pretty cool properties in a second. But I just want to point out something else also. This point right here at the top of the triangle, the x-coordinate is x, the y-coordinate is y. So I can kind of write it like this too, where I use an xy coordinate pair to say something about the legs of the triangle. Okay, so keep that in mind, that idea in mind. And now let's look at these special angles right here. We've talked about these previously in class. You remember that the sine of 0 is 0. The sine of 30 is 1/2. The sine of 45, root 2 over 2. And the sine of 60 is root 3 over 2. And the sine of 90 degrees is 1. And if you're looking for an easy way to remember these, remember that trick I showed you before. So what's 1 equal to? Well, that's like square root of 4 over 2. I don't know why anyone would write it like that, except for trigonometry. It makes something kind of useful happen, which is that you can rewrite these things like this. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2. Do you see the pattern that's going on here? It just goes like 0, what did I draw that? It goes 0, 1, 2, 3, 4. It's the 0, 1, 2, 3, 4 pattern. And that's very useful for remembering what these special trig functions are. And likewise with the cosine properties. Let's go over here. Cosine of 0 is 1. Well, I can write that as square root of 4 over 2. And cosine of 30 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. We have square root of 1 over 2. And square root of 0 over 2. Now, if you just want to write it 0 and 1, not these funny things, that's fine. Use this as a trick to help you remember them. Okay, now let's take all of this that you see on the page here, and I'm going to bring that down here. And now I'm going to make 3 separate triangles. These are your 3 special triangles. They have special angles in them, right? 30 degrees, 45 degrees, and 60 degrees. Now, let's start with the 30 degree one right here. I'm going to say sine of 30, we know that, is 1/2. Well, take a look at this triangle. That's right here, opposite over hypotenuse. So that is 1/2 divided by 1, which is 1/2. And if you look at the next triangle over, the red one, that's 45 degrees. What's the sine of 45 degrees? Well, that, according to this, that we talked about earlier, is square root of 2 over 2. And you can see, yep, that matches in this triangle. Square root of 2 over 2 divided by 1, which is just square root of 2 over 2. And I'm just going to change pace here. Let's go to cosine for a second. Cosine of 60, right? That's 1/2. And you can see that right here. 1/2, the adjacent side, divided by 1. Okay, now one more thing I want to do. Remember that idea of expressing a point at the top? The x-coordinate of this tall triangle is 1/2. The y-coordinate is root 3 over 2. And likewise, you can make dots for all of these things, where you say the coordinate of this point, this vertex right here, is root 2 over 2 in x and root 2 over 2 in y. And likewise, for this first one, we could say that's going to be root 3 over 2 for x and 1 over 2 for y. Okay? So, here's where we make a big jump. I'm going to now take those 3 triangles and put them on a coordinate grid, showing lots of things. And remember that the hypotenuse of those 3 triangles was 1. Well, if you imagine what's happening as you take this hypotenuse, it's like we're dragging out a circle. See that? It's like you take this hypotenuse and now you say, no, that's the radius of a circle. And the circle has a radius of 1. Let's call that the unit circle. And the reason we call it the unit circle is because the radius is 1 unit long. Okay? It's a memory tool for helping us remember what trig values are. And this is going to look pretty complicated. But as you get familiar with it, it'll actually be a very useful thing that you can use to remember these numbers. So if you look at what I've written here down in this part of the screen, you can see that these are basically all the numbers from the triangles above on a circle. And what I want to focus on right now is quadrant 1. Okay, I'm looking at quadrant 1. And in that quadrant, do you see that x is positive and y is positive? Right? X is only positive numbers. Y is only positive numbers. And as we learned before, way back here, remember what sine is. Sine is y. Cosine is x. So if x and y are positive, that means cosine and sine are positive. Okay, so you may be wondering, well, what's the big deal putting these 3 triangles on that quarter of a circle? The big deal is you can start to make trig statements about about angles that are bigger than 90 degrees. Let's look at this one right here. Check out this angle. What would that be? That would be, I think, if you count your way around the circle, right, that's going to be 120 degrees right here. Because you're going to go 60 up to the first green triangle. So if I go 60 that way, then this one must also be 60, because these are like mirror images. And if that's 60, then it leaves 120 on the other side of the angle, right, the supplementary angle there. So let's talk about that 120 degree angle. That has a point right here, just like the 60 degree angle did. And if you look at the y value, you see the y value is exactly the same. It must be, it's at the same level. So I haven't talked about the x value yet, but I know the y value is going to be square root of 3 over 2. How about the x value? Well, take a look at what's happening. This is a horizontal reflection over the y-axis. And when that happens, you switch the sign on the x value. So this is going to be negative 1/2, which kind of makes sense if you remember this is a coordinate plane. It's an xy coordinate plane. So now you can see we actually know what the cosine of 120 degrees is. It's negative 1/2. And likewise, we know the sine of 120 degrees is root 3 over 2. And you can use that same argument. Let's try a red triangle. Okay, I'm going to make a statement about the angle 135 degrees. Right, this guy right here is 135 degrees because it's the first one, 45 degrees plus 90 more. So that's my 135 degree angle. And if I said, what's the sine of 135 degrees? Well, sine of 135 degrees is basically me saying, what's the y value at the point G? Okay, what is this distance right here? That's the sine of 135 degrees, that y value. And if you look over here, you can see we have everything we need. It's root 2 over 2 and root 2 over 2. Just be careful. The y value is positive, but you can see the x value is negative. So we have to keep track of that with a little negative sign right there. Okay, and we're going to take this argument all the way around the circle. And I have pre-drawn this, so we're not going to spend forever on it. But here are all the special points as you go around the unit circle. And take a look, because you can see in each quadrant there are some very intuitive ideas. In quadrant 1, x is greater than 0 and y is greater than 0, which means cosine of theta is always greater than 0 and sine of theta is always greater than 0. But how about in quadrant 2? Well, over here, x is negative, which means cosine of theta is also going to be negative. But the y values are still positive because it's above the x-axis. So that means the sine of theta is also going to be positive. And same argument, down here, you see the sine of theta is less than 0, and the cosine of theta is also less than 0. And way over here on the right in quadrant 4, sine of theta is less than 0 because we are below the x-axis, and the cosine of theta is greater than 0. So the value of the unit circle is recognizing that the pattern we noticed in this first quadrant, right, when we were playing around with these numbers, that pattern is going to be repeated over and over and over again in each one of these new quadrants. It's just you have to manage the plus and minus signs. That's the only thing that's changing there. So it's really not 84 different numbers to memorize. If you memorize quadrant 1, you can find out what the cosine is of 225 degrees. Even though it's not even a real triangle at that point, you can still figure out the cosine of 330 degrees or the sine of 330 degrees. That's the value of the unit circle.